Now see a continuous charge distribution. We have done electric field due to discrete nature of the charges, like the charges are available Q1, Q2 and Qn. So these are the discrete nature of the charges, because the charges are available in the integral multiples. So we have calculated electric field at any point due to discrete nature of the charges, and also we have calculated electrostatic force due to discrete nature of the charges. Because the calculation is simple and it does not involve any calculus. But suppose the charges are distributed. Suppose we are taking like this line and charge is distributed along this line, then this is known as linear charge distribution, and in that case we cannot take discrete nature of the charges. So in the macroscopic level we have to take here linear charge density. Suppose this one has got the linear charge density is lambda. So first we consider a small length here, whose length is suppose dl, and we can calculate the charge of this small length. dq is equal to, suppose the charge here, that is equal to lambda into dl. So if the charge is distributed on the line here, or you can say here there is a line distribution of charge, then we can write dq is equal to lambda into dl, and by integrating we can get the whole charge, and then we can calculate electric field intensity or electrostatic force. So here we have to use calculus here. Now suppose the charges are distributed on the surface of the body, then we can take surface charge distribution. Suppose you have taken like this surface and charge is distributed on this surface, then we can take a small area n here, and this area is suppose ds, and we can take sigma is surface charge density. Then we can write here dq is equal to sigma into ds. So the charge on this small area is here, dq is equal to sigma into ds. So we have taken here the two linear charge density as well as surface charge density. Now after the surface charge density, suppose you have taken like this is a sphere here, and in this sphere there is the charges are distributed, then we have to use here volume charge density, and we can write here volume charge density, that is rho. We can sometimes we can say only charge density here. So sigma is equal to, we can write here now, sorry, rho dq is equal to rho into dv. dv is here small volume. So first we take the small volume and calculate the charge in this small volume, and then we can calculate the total charge in the whole body just by integrating it here.